And now we will look at dimensional analysis a third way. We can also use it to determine the dimensions of an unknown term in an equation, provided we know the others. We will use the same equation we've used before, since we will know what we should get for an answer, and that's a good check for us. Here's our equation again. Delta x equals v0 times t plus 1/2 at squared. For this example, let's say we were looking to see what are the dimensions of v0 to make this equation consistent. So we are looking for the dimensions of v0. There are a couple of different ways to do it. So let's look at the first method. Since the equation is correct, everything is equals, we don't need to put is it equals to. So L equals something, what we are looking for, times t. In the 1/2 at squared term, we know we can get rid of the 1/2 already. So we will right now. L over t squared times t squared. So L is something times t plus L over t squared times t squared is also L. So we have an L on the left and we need an L on the right. To add these two terms together, we have an L. This entire term must also be L. Well, if we have something times t, what can we multiply by t to get L? That would mean L over t should be here. If L over t times t, they would cancel, we would get L, and L plus L would be consistent. So the term we are looking for is L over t. The other way is to solve this equation for v0. As long as you solve it correctly, we could see what the dimensions would be this way. So let's solve this equation for v0. Solving correctly, v0 equals delta x minus 1/2 at squared, that whole thing divided by t. This could be shrunk down a little bit, but it is not necessary for what we are doing. So we're looking for the dimensions of v0. Well, let's see what the dimensions on the right side are. L minus, there's that pesky 1/2 again that won't appear, minus L over t squared times t squared, all divided by t. Next line, L minus L, as we see these cancel, divided by t. Now, L minus L is not 0, just like L plus L was not 2L. If you subtract the dimension of length from the dimension of length, you still have length. So this is L over t. This would be the dimension of v0, and we know from previous examples this is correct.